Okay.
Right. Using the calculator, you might get a calculator, non-calculator section of your test quiz. This is definitely a calculator question. So a ship travels 55 kilometers in bearing of 27 degrees, and then travels on a bearing of 117 degrees for 140 kilometers. Find the distance from the starting point to the ending point. They give you a picture. You'll notice in a lot of the rest of the problems there is no picture.
Mm-hmm.
That is sometimes a major problem for students, but um, that's just something to think about. One of the things you can do here is draw this line straight down. Why would I do that? Well, this is 90 degrees here, which means that this angle in here is 63 degrees. This is also 90 degrees, which means you have a right triangle. So you're trying to create a right triangle with the given information. Is that okay? Clear?
Mm-hmm.
All right, now I'm gonna, I guess I shouldn't use X. I'm gonna use A and B. How can we find A and B from what you guys have been doing in class? Just what do you,
We could do sine and cos to find A and B.
so let's start with sine. So the sine of 63
How do we
degrees,
know the hypotenuse is 25? I thought the
55.
height is.
Yeah, it's this 55 is referring to this right here, the blue.
Oh, sorry. Okay, yeah.
Um, so sine of 63 is what over what?
Um, B over 55.
Okay. How do you solve this for B? Yeah, give me just a moment.
Okay.
Sorry about that. There's
You're good.
waiting for that phone call. So I'll just answer the question here. To solve for B is 55 sine.
Sine 30 to 63.
Yes, and that's where you need a calculator. Make sure your mode is in degrees.
It would be 49.
Okay. I don't care about rounding, but your teacher might, so just keep in mind that could be an issue. To find
It's
A,
49.005. So then I
yeah,
just turned it to 49, right?
it's fine for me. Like kilometer is such a big unit of measure. Like I don't care if you're telling me 49 or 49.01, like that doesn't matter. It depends on the situation. Now, if we're talking about billions of dollars, yes, it matters.
Mm-hmm.
So cosine of 63 is A over 55. Okay, so A is 55 cosine 63.
24.97.
So we'll maybe say 25.
Okay.
Does that sound good?
Yeah.
Okay. So back to our picture here. Okay. We have we have we have another right triangle off to the right here, where this is 140 and B is 49. How can we find this other side down here on the bottom, which I'll call, I don't know. I don't want to use, let me just make up another letter. I don't want to use X because the X is the whole thing. Let me call it W. How do you find the third side of a triangle?
Pythagorean theorem.
Yes. Now, if you wanted to use sine, cosine, and tangent, you'd have to use the fact that this is 117 degrees and the whole thing, the whole angle is 180. So minus 117 is 63 degrees. You shouldn't be too surprised that they're the same, but that's possible. You could also use Pythagoras. You could also use sine, cosine, and tangent. So you actually have all these options. All of these are at your disposal if you want.
Okay.
So it doesn't matter to me, but you've got to somehow come up with W. I would just go Pythagorean theorem. It's easy to mess up sine, cosine, and tangent as a new student.
Mm-hmm.
Let me know what you come up with for that.
One 131.
Okay. So W is 131. And X is the one that goes all the way across. So we know that X is really A plus W. You found those two values. It's 25 plus 131, which is 156 kilometers.
Okay.
Any questions, thoughts on that?
I don't have any questions on this one.
Okay, let's do, I want to do, well, I don't know. They're all the same to me. I just wonder if ones are better than the other, but let's talk about this 21, number 21 here. This whole idea of a bearing only applies to like ships, maybe airplanes. I don't really know that much about airplanes. But it's like bearing of 40 degrees. It's like, what does that even mean? Well, it's from the north. So from the north, 40 degrees, you're going that way. That's the idea. Was that covered in class?
Yeah.
Okay, that's good. And then the second ship is 130 degrees. So that's again from the vertical. Why is it that way? I have no idea. That's what it is. So that would be 90. So 130 degrees is somewhere over this way. That's 130 degrees. And it's going down like that. So one of the things you can do here is you can draw these two without the angle measures. What is the angle between them?
Between
These two, between the black line and the blue line. What's the angle between them? This one's 40, this one's 130.
90.
What's the 90? Yeah. And you've got to be able to generate some right triangles out of this. So typically you're going to see that they're like 90 degrees apart or 180 degrees apart in these problems. Like you shouldn't be surprised by that, or 270 apart. All right. So now the first ship is going 18 knots, which is some sort of nautical miles per hour. I don't even know what that means. Like that doesn't mean anything to me, but it's going 18 something. Probably means something to people that are out on the water. But they're asking about 1.5 hours later. So maybe not in this course, but your distance is your rate times your time. So if you're going 18 knots and you're going 1.5 hours, that's 27. Is that clear how I came up with that?
Yeah.
Okay, the same thing applies to the one going 26 knots. Because it's going also 1.5. 39.
Mhm.
And so now there's some distance between them, which is the hypotenuse. So I would just use Pythagorean theorem to solve for the hypotenuse.
Okay,
All right, I need to just step away again for 30 seconds or less, and we'll be right back to work on 22 or
you're
23
good.
or 24. Be right back. Okay, so we didn't use sine, cosine, or tangent in this one, but we could have, like, we could have found this angle up here or this angle down here, maybe. We didn't need to do all that, but we could have. Because it was 90 apart. That was the big thing. They're 90 apart. That's really a big deal.
Okay.
Uh, okay. These are, I mean, I don't know. Are these like, what were you guys doing in class? Do like these types or other type, more like,
We did one like this, but it was like a combination of two separate compasses.
okay.
I can see if I can find it and send you the screenshot. Like number 28 that I sent you.
Oh, yes. Okay. Yes, we can do this. So I, believe it or not, have to like remind myself what it means with this bearing south and um I don't remember which one is first. So let me quickly look this up um so that I know how to explain it. Um A to C is north, 64 west. A to B is south, 82 west. Okay. B to C is north 26 east. All right. So I think what's really challenging here is to like know how to draw it. So
Mm-hmm.
because that's really where you're struggling. So let's just start with A, and you just choose a point for A. All right. So what this means right here, N64W means you start north, but you go 64 degrees that direction. So that's what A is. So C is up
So
here
if it
somewhere.
just said 64, then we'd go 64 degrees the opposite direction, right?
I can't say that. Like if it was a bearing of 64 degrees, it would be from the north. The bearing
Yeah, and then north and
is
it'd go east, right?
yeah.
Okay.
But from A to B, so A going to B, so B's over here somewhere, is south. So you're going south, and then 82 degrees, that's 82 degrees, that direction. And to go from B to C is like north, but then you're going 26 degrees east to get back to C. Is that okay?
Bearing C. I don't get where you got the 26 from.
It's right, this one right here.
But why would it be in that
If
spot?
you're going north and then 26 to the right. East is to the right, as you know.
Okay.
Is that okay? Is that, I mean, this is not standard stuff. Like even I'm like, I gotta look this up because I don't remember what the orientation is. Like, so up north, 64 west, south is 82, to
You know, that
to
makes
the
more sense.
west. Yeah. All right. So we need to find the missing angles. Missing angles. Okay. So first missing angle we need to find is this one in here. These three angles add up to 180.
So then it would be
You find that for us.
34.
Yes. Okay. Now the next one's a little bit harder to like comprehend. Um, these are parallel lines going down. And if you recall from geometry, these are in the interior. These are same side interior angles, or um, meaning that they add up to 180. So
Hmm.
the angle here plus this one adds up to 180, making it 98 degrees.
Okay.
You were lucky you didn't grow up in an era when that was a boy band, because that really, like it always is. Like, always think of the boy band. It's weird. Can't get it out of my head even to this day. Even though I didn't even listen to them. It's just you just hear it so often. You're like, all right, well. So now we can do the same thing to find this missing angle. Could you find that one for us, please?
56.
56. So for angle C, the missing angle, what must that be? The three angles add up to 180.
90.
Now you could have maybe reasonably assumed that that was 90 because it needs to be a right triangle, but that's not the right way to do it.
Yeah.
Um, so now, like there's a lot going on here, but here's what we have if we sort of just break away from this is we have 34 degrees, 56 degrees, and then it says to go from A to B takes 1.8 hours to go from A to B. We need the distance. Distance is rate times time. So we're given the time, we're given the rate, so we can calculate distance from A to B. Because we need one side of the right triangle. You can't do it without the others.
50 times 1.8. $630.
All right, so now we want to find the distance from B to C. We could be asked for any of the distances, right? Like they want this one, X, you could be asked for Y, for Y. So this is a sine, cosine, or tangent problem.
Okay.
So you can decide, like if you use angle 56, it would be cosine. If you use angle 34, it's sine, your pick.
Tan 56. Oh, wait, no,
No,
not tan 56.
we want to find X. So cosine
Cosine
56, yeah, equals X over 630.
630 cosine 56.
Yes.
352.29.
So that sounds reasonable. Let me check here. Yep. 353 miles. To find the other one, if you needed it, you would need to either use the Pythagorean theorem or sine and cosine again. But that's not really the hard part. The hard part is the drawing. So like I've done these, I'm kind of know what to do. You don't like if you're on a test or quiz, I would go to the instructor and basically ask like, is my drawing correct? And try to read their body language to see if they are willing to give you, even if they don't answer you, you know, maybe you can read something in there because it's big deal. If you don't have the right drawing, you might as well not even proceed with the rest of the problem. Really,
Yeah.
it's just not going to happen. So, um, 29 is similar. Maybe you do that one on your own. Um, we 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 um we should do something in the 30s that's more of the like, they give you like these two triangles and they kind of overlap. Like 35 and 36, kind of like one of those, and then maybe um I don't know. Then maybe a 33 or 34. Or we can keep doing more of these. What would be best for you?
33 and 34 is we do one more like this and then like 33 and 34.
Sure. We do 30 or 29. What do you want to? 27? Do you have a pick? Any of those stand out to you?
Um, not really.
All right, I'll do 30 because you probably don't have it in the back of your book in case you want to work those out later.
Mhm.
All right. Bearing from Atlanta to Macon is south 27 degrees east. So it's like saying I'm going to go south and then 27 east, like that. Bearing from Macon to Augusta. So that's A, we'll say that's M, is north 63 degrees east. So north 63 degrees, like that. One of the things one of these reason I was kind of weary of some of these is they make right triangles, which really help a lot. Um, that's what you're doing. So that's 63 degrees. And we don't know where Oh, that's Augusta. I guess I'll use G for that. So yeah. I don't like this problem because the angles that you're missing, this angle right here and this angle right here are equal by alternate interior angles, which is good. That means it's 27 degrees, but the whole thing is then 90. And so they're essentially giving you two sides of a right triangle. So they're telling you Atlanta to Macon is 62 times 1 1/4. So A to M is 62 times 1.25. And Macon to Augusta is 62 times 1.75, like that. So that's giving you two of the three sides of the triangle. So to find the third, you actually don't need to use any trig. You just sine, cosine, tangent. You just use the Pythagorean theorem for it.
Okay.
So I mean that's maybe we ought to do 20. So like when I look at 28, see how there's a 64 and a 26. Those are going to add up to 90. It's going to make some sort of a right triangle. Same with 27. There's a 52 and a 38. Those are going to add up to 90 to make them sort of a right triangle. So when in doubt, I guess make it a right triangle.
Okay.
Is that okay? Is that okay?
Yeah.
Right. So I wanted to do 35 or 36 first because I wanted to um I wanted to do one where they give you the drawing because it's much easier than making the drawing.
Mm-hmm.
So I'll tend towards the one that's the even, so you don't, because you don't have the answer in the back. Although I think these are all available online now. I don't know. They used to not be. There's actually two triangles here. There's the one on the right, and then there's the big one. You could draw them separately. The reason is you want to not be distracted by things that are there. So this right here is unknown. Let's call this X right there. So this one on the left here is 168 plus X. Okay, and these are the harder problems. These are the ones you probably started seeing towards the end of class. They're gonna have two variables. You have to solve two equations. Does that sound like something you guys are doing in class or not quite yet?
We covered it a little bit in class, but I think we're gonna go over it tomorrow too.
Okay. So the problem is like in all the other ones, or the issue here is with all the other ones we've been doing, you were given enough information to find everything in the right triangle. It's like now you're not. Now you're like, what do I even do here? Well, you have to be told this, but the tangent of 52.5 on the right equals h over x.
Mm-hmm.
You can't solve anything. You can't do anything with that, but you have an equation. What's nice is that the heights are the same. They're the same in both triangles. So guess what you do here is you make another equation in tangent. Tangent 41.2 equals h over 168 plus x. Now this probably looks awful. Probably looks like how do you even solve this? But in just like very simplistically, you have two variables and two equations. So you should be able to solve this. Like it's not beyond your ability, but because it's a tangent, maybe because it's rational, you're like, I don't know how to do it. But you can. Like it's just two equations and two unknowns, believe it or not.
Yeah.
Okay. There's a lot of algebra from here, but is this clear how to proceed on this problem so far? Like is it clear not how to proceed? Is it clear how we set it up? Because from here it's just algebra, it's just solving equations, but like you have to be able to set up these two tangents in your own problem that we're gonna do.
How would we solve these though? Because there's H
Yeah,
and.
yeah, we're gonna do that right now. It's a lot of work, so I don't want you to get like I want to make sure you're okay. Do you feel like you could replicate this for like 35 if you had to?
Yeah.
Okay. Now, how to solve them. So you always solve for h. First, h equals x tangent 52.5, like that. And this goes into the other equation. So this is tangent of 41.2 equals x tangent 52.5 over 168 plus x. Now this looks really, really bad. Now, if you really don't like rewriting tangent over and over again, go to like 4 decimal places. But I like keeping it. It doesn't bother me, but I get it. Like if you're a student, you're like, I really want to see numbers there. You can do that if you want. But that's the first step. Next thing is to clear the bottom. So you clear the bottom by multiplying both sides by the bottom. Okay, so that goes away. On the left, you do distribute this tangent into both. So it's 168 tangent 41.2 plus x tangent 41.2 equals x tangent 52.5. You get your tangents on the same side. I'm going to move this one to the right. So you have 168 tangent 41.2 equals x tangent 52.5 minus x tangent 41.2. Factor out at x from both. Tangent 41.2. Divide both sides by this thing on the right. So x equals 168 tangent 41.2 over tangent 52.5 minus tangent 41.2. If you are going to put this in your calculator, but you do need to make sure you have an extra set of parentheses on the bottom there.
Okay.
Anything about that unclear?
Mm, no.
Okay. So could you calculate this for us, please?
I got 343.46.
Yeah, it seems reasonable.
Hmm?
344 maybe. Okay. Now that's not the answer. If we go back to the problem, you're like, what do you mean that's not the answer? They want H. So
Oh,
you're not quite done. You've got just a little bit more. H is x tangent 52.5. So just be aware that you may not be totally done when you get your answer. And because these are physical problems, like sometimes you don't know if they're like you don't know. You're not like, well, does that even make sense? Like, well, maybe. I mean, I don't really know what this physical situation is. So, um, yeah, you got to do that last part there to get the height.
448.
Okay.
Oh.
I'm not checking these. You know, like this is correct. This is just a calculation. So that's another reason to maybe leave it out like this is you don't, this is the correct answer. You should have units, I suppose, if you really wanted, but this one didn't have any. I guess it did have meters in it. Meters. Any questions, thoughts on that?
Mm, no.
Okay,
Do you think you'd like quickly explain what you did again, though?
sure.
Quickly go over it.
Okay. Why don't we do this actually? This will be better. You said you understood this part. Maybe. Yes, no, maybe.
Yeah.
Okay. Why don't you try setting up the two equations for 35? And then I'll solve 35. You can see that. But I want you to set up the two equations. They're very similar.
35.
Yes. Do you have it on? Do you have the ability to pull it up or do you need me to snip it in?
If you could put it in, that'd be great. But I can
Okay,
check if you need.
got it. All right. So there's two tangent equations. Go ahead and, call this X.
It'd be the same drawing that we did for the last one, but instead it would be 392 feet and then 392 plus x feet for the 492-degree triangle.
So there's two equations. There's, tangent of 49.2 equals something over something. And then there's tangent of 29.5, which equals something over something. That's just trying to get you to write down for us.
Oh, okay.
And you can make the drawings if you want, and then solving them is very algebraically intensive, but
Yeah, tan 49.2 would be h over x, and then tan 29.5 would be h over 392.
plus x.
Yeah.
Because it's the big triangle.
Oh yeah.
It's 392 plus x there on the bottom. Okay. Now you always solve the first equation because you want to substitute in for h. You can do it, but for the other variable, it's way more difficult. You try to limit the challenge here. So try to remember that. That's important. And there's other ways to do it. I just always solve it for h. So this is h equals x tangent 49.2. And that goes in there. So the solving it is it's a substitution method. You solve one for one variable, then you substitute it in for the other. So this is tangent 29.5 equals x tangent 49.2 over 392 plus x. And notice we're down to one variable when we do it this way. Any questions about that before we continue?
No.
All right, so you want to get the variable out of the bottom. The only way to do that is to multiply by the bottom. And it's good we're doing two examples of this because this is a common test question that you see. They really, really like this. On the left, you distribute this tangent 29.5 into both. And like I said, if you really don't like writing the tangent over and over again, you can round it to 4 decimal places if you're going to.
So then it would be
So we're almost there. You got to get the x's on the same side.
so you just do x tan 49.2 minus x tan 29.5.
Yes.
It'd be 222 equals the x tan 49.2 minus x tan
Yep.
29.5.
Yeah. And then you factor an x out of both. And then you divide.
Oh, okay.
So you're dividing, like this is a number over here on the right, even though it looks like something more complicated. It is some sort of a number. And then you divide both sides by that. 392 tangent 29.5 over.
0.59.
Again, if you're going to go to the calculator, make sure you got to enough decimal places. That may not be enough. You may be way off in your final answer. So I wait until the end to do the calculation. But if you're going to do the intermediate calculations, round to like 4 decimal places.
What do you mean end of the problem to do the calculation? Like what I not
I
do
don't,
right now.
I don't go to the calculator until this point. Like you did it here, I wouldn't do it. I would put all this in the calculator.
Okay, that's like a whole equation.
Yes.
374.17.
Okay, so just like before though, they want the height, so you're not quite done. You have to go back to the height equation, which is x tangent 49.2. So one more step.
$433.
Okay. Don't forget your units if there are any. Um, any questions on that?
I don't think so. That
You
makes
will get
sense.
you will get something like this. You may have to set it up. Um, so maybe that's what we'll do over the last 2 minutes is we'll just set up like one of the like 34. We'll set up the triangles. So let's do that real quick. All right, the angle of elevation from Lone Pine to the top of Mount Whitney is 10 degrees, 50 minutes. Hiker traveling 7 towards, okay, so here is the scenario. The hiker is here. And he looks up and he says, there's the top of the mountain. That's the 10 degrees, 50 minutes. Is that okay? Clear? He looks to the top of Mount
Mm-hmm.
Whitney. That's Mount Whitney up here. But then he walks 7 kilometers. We don't know where this, but he walks 7 kilometers. Now he's here. He looks up again. He says, ah, I'm a little closer. And he's actually 22 degrees and 40 minutes. Find the height of the top of Mount Whitney. So this is H, this is X. You see how it's the exact same setup as 35 and 36.
Yeah.
Now, quickly, remember how do you remember how to convert the 50 minutes to a degree? You divide it by 60. Same thing with the 22 degrees and 40 minutes. It's 22 plus 40 divided by 60.
Mhm.
All right. So if you want, you can work that out. It's exactly the same. If you do enough of these, you'll find the pattern for how to do it, but you still have to show your work. So just be careful that you don't do
Okay.
that. All right. Thursday, we're all scheduled for Thursday. Let me stop the recording here.